Hello guys, today we are going to discuss fundamental concepts within 5G core architecture, that is session and service continuity, or you can say SSC mode. So in previous generation of mobile networks like 4G LTE, mobility was kind of generally handled by maintaining a single stable anchor point in the core network to preserve the user IP address as they are moving. However, 5G introduced services such as multi-access edge computing where forcing data traveling back to central or you can say distant anchor point is not going to satisfy the purpose of special use cases of ultra low latency. Okay, so to solve this, 3GPP defined three distinct SSC modes, and these mode tells exactly how a user data session and their IP address is managed as they move across the radio network. So now we have SSC mode. This is the traditional approach this is kind of traditional approach like for GPC. Here UPF act as a kind of fixed stable anchor as the user equipment moves from one NR or new radio cell to another. The PDU session is maintained through the exact same UPF. And because UPF doesn't change, IP address is preserved and the existing IP session will be the same. And in the use case for this is this mode is essential for application that simply cannot handle the IP address change, such as voice call, or you can say VNR, or you can have a continuous VPN connection, or some basic mobile broadband browsing where IP persistence is kind of required. Then we have the SSC mode 2 that we call as break before make approach. Here the network keeps the UPF close to the user to maintain low latency. As the user moves, the network determines that the original UPF is kind of too far away. So the network terminates the connection to the first UPF before establishing a new connection to a new closer UPF. Here UE kind of drops IP address 1 and acquires a completely new IP address, that is IP address 2, from the new UPS you can say. And here the old session is broken and a new IP session is set up. And use case you can see because there is interruption in services while the new session is established. This mode is designed for applications that are resilient to some brief disconnects and kind of IP changes, but need some low latency. So examples are kind of edge computing application like a smart city sensor or some content delivery network. And here the application is going to quickly reconnect to the new IP. Then we have the SSC mode 3, that is make before break approach. So here mode 2, here the goal is to move the anchor point to a closer UPF to optimize routing. However, mode 3 is kind of ensure there is zero downtime. Okay, so as the user moves, the network provision a new PDU session with the new UPF while old session is still actively kind of passing traffic. Here, for a brief period, the UE actively holds two active sessions with two different IP addresses, and that is IP address 1 and IP address 2. And once the application traffic is successfully migrated to the new session, the old IP session or IP address 1 will be released. And here use cases is this can be built for mission critical edge or Mac application, or you can see vehicle to everything autonomous driving, remote robotic surgery, automated vehicles in some smart factory. These applications need to be handled of nearest as servers for low latency, but a dropped connection here even for milliseconds is kind of unacceptable in this case. So to summarize this, we have to use mode 1 when the IP address absolutely need to be changed, so traditional mobility. And then there is we have to use mode 2 when you need as routing efficiency and application can handle a brief disconnect. Okay, and we can use mode 3 when you need kind of both as routing efficiency and zero downtime. And I think that's it from this particular slide. I will see next slide. Thanks.